Okay, we're going to continue our study of triangles by looking at some inequalities associated with triangles. So, first of all, let's just think about something that's kind of common sense. Let's suppose we've got a triangle and it has a particular angle here. Okay, and I'll connect this with a side. And we're looking at this angle right here. Now notice this is a triangle. This angle right here is related to the opposite side over here. Now look what happens if I make this angle bigger. Well, now I no longer have a triangle unless I extend this side. Okay, now I have a triangle, but notice the angle is bigger. Now, this thinking helps you to realize that the sides opposite bigger angles are going to be bigger than the sides opposite smaller angles. So the bigger angle, the longer the side opposite, and vice versa. The longer the side, the bigger the angle opposite in comparison to the others. So that's what these first two theorems deal with here. Theorem 5.10 and 5.11. So look at this. We've got two triangles down here. Let's look at A. And we want to find out, well, what is the longest side? Well, the longest side is this one. This is number 1 right here because it's opposite the 100 degrees. The next longest side over here is the 45, opposite the 45. And then finally, this is the smaller side, the smallest, the side opposite the 35. Now, we could talk about angles. Well, which angles are bigger? Well, the biggest angle is going to be opposite the 8. Okay? So this is number 1 for the biggest. The next one, opposite the 7. The next one, opposite the 5. So there you go. This is the largest, the next to the largest, and the smallest. So that's kind of, that makes good sense to us. Okay, so this is something to keep in mind. Now, we want to look at this exterior angle inequality. Now, it basically says this: if you have an exterior angle, this exterior angle here is going to be bigger than either one of these opposite angles over here. So the measure of an exterior angle of a triangle is greater than the measure of the two non-adjacent interior angles. I said exterior. These ones over here. So in other words, measure of angle 1 is bigger than A, and it's bigger than B as well. Now, let's see how we could go about proving that. Let's just see if we can look at this. Here we've got a statement, and over here we've got reason. Now, first of all, let's just start off and we say angle 1 is an exterior angle. And that's given. That's just something that's given to us. Okay? Now, what else do we know? Well, one of the things we know is that the measure of angle 1 plus the measure of angle C is equal to 180 degrees. And this is because linear angles are linear pair are supplemental, okay? So linear pairs are supplemental. Yeah. Now, we also know this. We also know that the measure of angle A plus the measure of angle B plus the measure of angle C, we know that that is 180. Because, and the reason we know that, let me give myself a little more room over here. Move this down. So, the reason we know that is because the sum of angles in a triangle is 180. Okay. Now, you don't have to try to remember the name of the theorem. There's a name for that theorem, but let's not get bogged down in that. Let's just think about the reasoning. Now dig what we have here. we have the measure of angle 1 plus the measure of angle C is 180. And the measure of angle A plus the measure of angle B plus the measure of angle C is 180. Therefore, the measure of angle 1 is equal to the measure of angle A plus the measure of angle B. And the reason for that is because they're supplementary to the same angle. Okay, so they're supplementary to the same angle. So we can make that, okay, we can make that conclusion because they're supplements to the same angle. In other words, that sum, now really I'm talking about two angles here, but A plus B, that number would act as a supplement. I mean, I guess that's not really, when you talk about supplements, you're talking about two angles. But I'm saying, okay, these both are adding up to 180 for the, I guess one of the things I could say is I could say substitution. I could just say substitution. Okay, substitution. Because, you know, I got to thinking, I was talking about three angles, or two angles being three angles being supplemental, and maybe that's not appropriate. But anyway, this is what we have. Okay? Now, here's what we have. We have this. We have the measure of angle 1 minus the measure of angle B is equal to the measure of angle A. And the measure of angle 1 minus the measure of angle A is equal to the measure of angle B. Okay? Just by, subtraction property. Therefore, the measure of angle 1 is greater than the measure of angle A, and the measure of angle 1 is greater than the measure of angle B. So for this one, I would just say definition of addition. Of positive real numbers. Yeah, definition of addition of positive real numbers. Okay. Now remember, you don't get bogged down. Just go through here, and the reasoning is what's important. Okay. And the next thing we have is the triangle inequality. And it says this, that if you have the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So, you could have a triangle like this. You could have, let's see here, we've got 1, 2, 3, 4, 5, or 4, let's say, and here is 1, 2, 3, and this, okay. Now, this is a 3, 4, 5 right triangle. This is a right triangle. This is an example. Now, you notice this, that any two sides, 3 plus 4 is bigger than 5. 5 plus 3 is bigger than 4. Okay? And you could say 5 plus 4 is bigger than 3. See, the sum of any two sides is going to be bigger than the third side. Now, that has to be the case. If that's not the case, then it's not a triangle. So let's just look at how we could work with this property. Let's suppose you have a triangle and one side is 10 units and another side is 14 units. And what we want to do is we want to figure out, well, what are the ranges of lengths of the other side? In other words, how small can that other side possibly be and how big can it possibly be? Well, let's call that other side X. Okay? Now, Let's see what we could do here. We could say, okay, 10 plus x, that has to be greater than 14. Okay, so now just solving this, we get x greater than 4. So one of the things we know for sure is that x has to be greater than 4. That other side has to be greater than 4. Now, let's go the other way. Let's look at this. 10 plus 14, that has to be greater than x. Okay, so let's see what we've got here. We've got, this is 24 greater than x. Okay, now this means that x has to be less than 24. So here's the deal. X has to be greater than 4, and it has to be less than 24. So we've done it. So if we have an x value anywhere between 4 and 24, not including, then we have we have a triangle. In other words, all the sides can connect. Now, if you have a situation where this triangle inequality doesn't hold, then if you try to sketch out this triangle, it won't work. So for example, let's suppose you have 1, 1, 3, something like this. Or let's do this. Let's do 1, 10, and 2. Let's suppose you have a triangle with those sides. That won't work because 1 plus 2 is not greater than 10. And if you try to draw a triangle with these sides, you're going to fail. Okay. So those are the inequality theorems related to triangles that we'll study.